Alright, word of warning, my dog just saw a squirrel outside, and so she's real jazzed. So if she starts barking in the middle of this, I'm really sorry. Welcome to teaching from home. So here's the things that we've done with quadratics so far. We've graphed quadratics, we've done the vocabulary for quadratics, we've transformed quadratics, we've written quadratics using regressions. One of the main math things we haven't done with it yet is solving quadratics. We're going to learn like 4 or 5 methods to solve a quadratic. Today is the first method. It is called solving by factoring. Okay? We spent a bunch of time in the 4-6 weeks factoring quadratics or just equations. Didn't know they were quadratics yet. And this is why. Because we can solve quadratic equations that model projectile motion using the process of factoring. Super duper fun and super important. There's 2 things we need to talk about, though, before we review factoring, which we've done already last week, and show you how to solve the quadratics using factoring. The very first thing is that when you are given a problem, like this one that says, what are the solutions to 4x squared plus 4x minus 3 equals 0? You have to notice that this equals 0 is super important. If your equation does not say equals 0, you cannot start. So let's say it says something like this one. 4x squared plus 4x equals 3. Do you see how that 3 is on the wrong side, that it doesn't say equals 0? So before we get started, anything that's on the side that should be a 0 needs to be moved across the equal sign. The cost of moving something across the equal sign is to change it to its inverse operation, which is why we have 4x squared plus 4x minus 3 right here. Because it was a positive 3 when it was on the 0 side of the equation. And so we just move it over, and now it's positive. Okay? From this point on, since we're solving by factoring, this should look familiar to you. We set up and solve an X puzzle. If you remember, hopefully you reviewed this last week like we asked, but there are a few things that are involved in an X puzzle that you need to remember. You need to remember first that there's going to be an A, a B, and a C. And then you need to remember how to set up an X puzzle. Hopefully you remember that A times C goes in the top, and B goes in the bottom, B for bottom. So 4 times negative 3, Miss Quigley, that's a negative 12. You are correct. Okay, 4 times negative 3 is negative 12, and then the 4 from the B goes into the bottom. Now underneath the division signs is the A, so that's 4. I find 2 numbers that will multiply to negative 12 and will add to 4. The numbers that multiply to 12 are 1 times 12, 2 times 6, and 3 times 4. Now my green piece of paper, which I know you don't have, I will post the green piece of paper, the pictures from the green piece of paper here in a little bit. But it would remind you that if the top number is negative and the bottom number is positive, that the bigger number is going to be positive and the smaller number is going to be negative. So the way that we can make 4 out of that pattern is not with either of those 2 rows, but it's with this one. And since 6 is bigger, it gets the positive, and since 2 is smaller, it gets the negative. When we factor and we've figured out the X puzzle numbers, we reduce the fractions. If I reduce negative 2 over 4, I get negative 1/2. If I reduce positive 6/4, I'm going to get 3/2. Those are the exact numbers that come down into this line of the factoring. This is the part that a lot of y'all kept skipping when we were doing factoring. You were getting ahead of yourself. Here's where I don't want you to skip it. This is positive 3/2, and this is negative 1/2. If I had asked you to factor, yes, you'd take those denominators and you'd swing them forward, but I'm asking you to solve. This is the difference. From here, you know immediately that your solutions, highlight the word solutions if you will, your solutions are the opposites of those numbers. So the opposite of positive 3/2 is negative 3/2, and the opposite of 1/2, or negative 1/2, is a positive 1/2. These are the opposites. Okay? Factors and solutions are opposites. But we want the fraction version, we don't want to swing it forward. Okay? Again, these are the opposites. So I'm going to flip the sign for each of these when I'm writing down the solutions. But what's cool about finding the solutions in this process of factoring is that I also now know what the roots, that's not a highlighter, what the roots, zeros, and x-intercepts are, because those are a part of my rocks words. And my rocks words are all the same. So my roots will also be negative 3 over 2 and 1/2. My zeros will also be negative 3 over 2 and 1/2. And my x-intercepts, negative 3 over 2 and 1/2. Boom! I know a lot of information once I know how to solve by factoring. But I do want you to remember that the factors themselves would be swinging the denominators forward. So if I hadn't asked you to solve, if I had asked you to factor, that's a different verb than solve. You would have to swing that denominator forward, and I forgot the x. 2x minus 3 and 2x plus 1. That would be the correct factors, but I'm asking you for the solutions, which are the opposites of the fraction factors. It all comes back to haunt us. Let me walk through this problem one more time since this is the only example you get on your notes. If you need factoring help, there's whole videos for that, but I'm going to walk through solving by factoring just one more time. So we started off by making sure it was in standard form, which means that it's set equal to 0. Check, it's set equal to 0. We then set up and solve an x puzzle. A times c goes in the top, b goes in the bottom, a is underneath. We solve the x puzzle like normal, positive 6 and negative 2. We play the reducing game on each side and take those exact numbers and put it in the first version of factored form. And since we're solving, we pause. And we say, all right, well, if those are the fraction form of the factors, then the solutions are just the opposites. Instead of the positive 3/2 that I put in the factored form with the parentheses, the solution is negative 3/2. Instead of negative 1/2 in the factored form, the solution is positive 1/2. If I'd asked you to factor, though, you do swing that denominator forward. This is the difference between factoring and solving. Please know the difference between them. And that is all we're asking to do today. Solving by factoring is really, really cool. The difference between solving and factoring is important, though. Factoring ends here. Solving ends with numbers, the opposites of these. We empower, we impact, we love. We are Skeeter Nation. Good job, Tilly, you didn't bark. Sorry, you thought you were done. I just realized I forgot to show you how to check your work. Okay, we did all the notes. We know what our solutions are. Here's how you guarantee you never get this wrong. The solutions, since they're part of our rocks words, we're going to be able to use that idea and use Desmos to check our work always. So once your equation is set into standard form, we can go to Desmos and we can type that in. Oop, this is from the last video I was doing. So let's type in the equation. Standard form, which means it's set equal to 0, 4x squared plus 4x minus 3 equals 0. Okay, if yours is giving you an error message, sometimes getting rid of the equals 0 helps. Okay, but here we know that our solutions are also our y-intercepts. And we had answered that ours was negative 3 over 2 and 1/2. Now, if you don't remember the fact that negative 1.5 and 0.5 are the same as negative 3/2 and 1/2, type those into Desmos and make sure those check out. We are guaranteed that that was the correct way to solve by factoring because of this. Because these are also our rocks words and solutions is one of the rocks words. We can always factor and solve, or solve to factor, factor by solving, and then throw the question into Desmos and make sure that our solving is correct, because factoring to solve and graphing to solve are two of the methods we're going to be using to solve quadratics. So this is how you check your work. If these don't match up, what you got is an answer choice. If the negative 0.5 and 0.5 are not what you got as when you factored it, you did not do it correctly. So there's always a way to check your work. Now I'm done. Sorry. Goodbye.